G'day! Today I want to talk about a very famous puzzle in probability theory called the two-girl paradox. It's called a paradox because its answers are actually very surprising and very confusing and very subtle. It's about meeting some fathers. So Albert, who we've met, tells you he's the father of 2 children and that his oldest child is a girl. And the question is, what are the chances that his other child is also a girl? Okay, fair enough. And then Bilbert, who you've just met as well, tells you that he's also the father of 2 children and that one of his children is a girl. What are the chances that his other child is also a girl? Now, did you catch the difference there? There's a slight difference here. Albert specifically tells us his oldest child is a girl, whereas Bilbert just says one of his children is a girl. Okay, maybe it's not that much of a difference. Okay, grand. We'll think about that in a moment. But then it comes along Cuthbert, because Cuthbert says, he's also a new acquaintance, that he's the father of 2 children and that one of his children is a girl born on a Tuesday. What are the chances that his other child's also a girl? Okay, this just seems so confusing because the questions feel like they're basically the same question. Surely that Tuesday thing is like a random piece of extra information that's not going to affect anything. Surely the answers are actually the same because after all, think about this. Each is saying, one of my children is a girl, therefore we're asking, what's the probability the other child's also a girl? Well, I guess in populations, being born boy or girl is 50-50, so the chance of the other child being a girl is 50%. That seems like the reasonable answer. 50%, 50%, 50%. And that seems a fine answer. It seems a fine answer. Though you get nervous because it starts to feel too easy. Do these subtle changes of information or wording information affect the answers anyway? And here's the thing. Mathematicians will say, yes, the slight change of wording does actually affect the answers. In fact, mathematicians might argue the answer to Albert is still a half, they'll agree with you there, but they might say, oh, but when Bilbert says one of his children is a girl, that information changes the probability of the other being a girl as well to 1/3. And then they say, this information about being born on a Tuesday, I know it seems irrelevant, but actually it's not irrelevant. It changed the chances. It changed the chances to this crazy number, 13/27. Whoa, where does that come from? That seems insane. But here's the thing. You can argue that these beginning answers are absolutely valid and correct. And you can also argue that these mathematicians' answers are absolutely valid and correct. And you can argue other sets of answers are absolutely valid and correct because it turns out this question is ambiguous. And most people don't realize it's ambiguous until you start to think really, really deeply about it. So what I want to do now is share with you the ambiguity that lies within this puzzle and how you interpret different things in different ways can actually lead to different valid answers. Are you with me on that one? This is going to be fun, it's going to be wild. So see if you can follow what's going on. We'll do Albert's case, we'll do Bilbert's case, and we'll do Cuthbert's case and see that maybe this Tuesday information sometimes does affect information and sometimes doesn't. All right, here goes. So let me clean this part of the board. So what I want to do is imagine going through this scenario some large number of times. That is, I want to meet a large number of fathers with 2 children. In fact, let me say we're going to meet 1,960 fathers, which seems a crazy number to pull out of the air, but I did that because I'm thinking ahead because each father here has 2 children, which can either be a boy or a girl, or a boy or a girl. That's 4 choices. And then I got nervous about this Tuesday thing. There are 7 days in a week and a child can be born on one of 7 days. So I thought, okay, I want 2 choices, 4 choices, and I probably want a factor of 7 for the day of the week of the first child, and I probably want another factor of 7 for the day of the week of the second child. So that's a factor of 49. Well, 4 times 49 is 196, so I made sure there's a 49 in there, and I also made there's a factor of 4 in there, and also just multiplied by 10 to make it a big number. That's all I did there. Okay, I was just trying to think ahead so that I can have factors of 7 if ever I need them, and factors of 2 and factors of 2. Great. All right, so let me just collect some data about 1,960 fathers in general. Now, if they're fathers of 2 children, they will have an oldest child and they will have a youngest child. Even if they have twins, one twin is always born a few seconds before the other, so there's definitely one oldest child and one youngest child. So in ideal circumstances, amongst 1,960 fathers, half of them will have oldest child being a girl, and half will have oldest child being a boy. In fact, it would be what? 980 of them would be girls, have girls as oldest child, and 980 of them will have boys as oldest child. Now, amongst these 980 with girls as oldest child, they have a second child, so the younger child could either be a boy or a girl. In fact, we believe half and half. Half girl, half will have girls as a second child, half will have boys as a second child. So actually this 980 splits into 490 with second child girl, 490 with second child boy. And ditto, for these fathers with oldest child a boy, half will have second child girl, half will have second child boy. Beautiful. So there is the data of all fathers of 2 children. They either have girl or boy for oldest, girl or boy for second, and each possible pairing comes in equal likelihood. 490 of this group, 1/4 of them, will have girls. 490 will have a boy, then a boy. 490 will have a girl, then a boy, and 490 will have a boy, then a girl. Grand. So let me now go through Albert scenario, Bilbert scenario, Cuthbert scenario, based on that data. All right, Albert. I guess I wrote him in blue, so I'll keep going in blue. So what's Albert telling me? Albert we've just met, great, tells you he's the father of 2 children. So he's somewhere in this picture. He's somewhere either here, or he's here, or he's here, or he's here. And that his oldest child is a girl. So he told me his oldest child is a girl. So he's actually telling me he's in this part of the picture. He's part of this 490 there, or the part of that 490 there. We don't know which one. He says oldest child a girl. But the question is, what are the chances his other child is also a girl? So of these 980 possibilities, we're wondering what are the chances of him being here in the girl part of it. Oh, well that means there's 490 chances of him to have a girl-girl combination out of 980 possibilities. The chances must be 490 out of 980, which is indeed 1/2. The chances that he has 2 girls, the chances he's in this part of the picture, knowing that he's in that part of the whole picture, is half the picture that we're looking at. Half. So yes, I agree. The probability that Albert's second child is also a girl is 50%, 1/2. All right, so that's Albert. I have no quibbles with Albert. The trouble is Bilbert. Because Bilbert did something strange. Bilbert just says the gender of one of his children is a girl. He just chose a child. Now, what made him choose a particular child? And that's the crux of the matter. We don't know what made him choose a particular child. For example, he may have had a coin on the side and said, okay, I'll flip heads. If it comes up heads, I'll mention the gender of my oldest child. If it comes up tails, I'll mention the gender of my youngest child. So we don't know what he did. So maybe he flipped a coin, and it turns out he did a coin flip, and they said, oh, according to my coin flip, I must speak about this child, and it turns out that child's a girl. Okay, so let's go with the coin flip. If Bilbert chose which child to talk about by flipping a coin, here's the answer we get. Okay, so let's assume Bilbert flipped a coin to choose which child to mention. He mentioned one of his children as a girl. Alright, so where is he in this picture? Well, he's not in this part of the picture. He's not in the boy fathers because he mentioned he's got a girl, so we know he's not there. He's not one of that 490. Oh, I'll do this in green. Hang on, green. He's not part of that part of the picture. Now, he flipped a coin. If he's in this part of the picture, girl, then no matter what the coin flip comes up, he's going to say, my child's a girl. So he'll be, all these people here would say, under this circumstance, one of my children's a girl. Whereas here, if you're a girl-boy father and you flip a coin, half the time you'll be talking about your oldest child and you'll say you have a girl, and half the time you'll be talking about your youngest child and you'll be talking about mentioning you have a boy. So half the people here via coin flip, so half these people, 490, oh gosh, what is that? That's 245 of these people will say, I have a girl. One of my children is a girl. And ditto for this one. Half these people, when they flip a coin, will be talking about their oldest child and will say boy, and the other half will flip a coin and get their youngest child and say girl. Well, you said girl, so you must be part of that second possibility, one of the 245 people that flipped the coin, got the youngest child and said girl. So what's the probability then? Well, we're asking, what are the chances he has 2 girls? What are the chances he's being in this part of the picture now that we know he's in this whole picture? Well, this whole 3 squares of the picture. Well, the answer is he can be one of the 490 out of a total of 980, which is 1/2. So actually, our intuitive answer is the right answer under this assumption he flipped a coin to choose a child, but maybe not for the reasons that we said before. It's actually much more subtle reasons, 50%. But, there's other ways that could have motivated Bilbert to talk about which child to mention. So let me put the data back, put the data back, put the data back. Here's a strange scenario. Suppose that Bilbert lives in a society where you must mention you have a girl child if you legitimately can. It's the law, you must mention they have a female child. If that was his motivation for mentioning one of my children's a girl, then that's going to change everything. All right, so let's now imagine Bilbert's in a society that says he must mention he has a girl if he can. In which case, of these 490 people, could he be one of those people? No, they cannot mention they have a girl, so he's not one of those people. All right, if you're one of these people, yes, he'll say one of my children's a girl because he has a girl. Could he be one of these people? Yes, in that society, he would be forced to say one of my children's a girl because he has a girl. Could he be one of these people? Yes, because in that society, he has a girl, therefore say one of my children's a girl. So under that situation, we're asking what are the chances that he has two girls that he's there in this part of the picture? And now you can see the answer is, oh, the chances he's in this part, given it could be any of these three parts, which is 3 490s, you can see is 1/3. So under that motivation for how Bilbert chooses which child to talk about, we now get the answer 1/3. Surprise. So you can argue the answer 1/2 is valid. You can argue the answer 1/3 is valid. In fact, you can come up with other motivations will give you other valid answers for Bilbert's predicament. All right, Cuthbert, let's do the same thing. So, Cuthbert, we should leave both numbers on the board. So 1/2 and 1/3, they both go on there, and you can actually come up with other answers as well. So Cuthbert, let's go back to the full situation. Except now I'm worried about that Tuesday comment. So that means I have to split my diagram into a bit more information because I need to talk about girls born on Tuesdays and girls not born on Tuesdays and I guess just boys. All right, so let's do this. So let's now split this picture up into Tuesdays and non-Tuesdays for the girls, Tuesdays and non-Tuesdays for the girls. I don't have to worry about the boys. So if I do that, I'm going to assume 1/7 of the people on this planet are born on a Tuesday. So that means amongst all these girls, I have girls on Tuesday and girls not Tuesday. So you can't read my handwriting here, but there used to be 490 of them, but 1/7 of them will be here, and that means I guess 420 of them will be there. I guess ditto for the boys, 1/7 and 420. Yep, so I split the oldest girls into girls on Tuesdays and just girls not on Tuesdays and left the boys alone. Now, let me now do it for the youngest children. So I now have girls born on Tuesdays, and girls not Tuesday. Okay, my handwriting is atrocious, but maybe we're okay. And I'll leave the boys alone. But of these 70, 1/7 of them will be born on a Tuesday, leaving the rest not on a Tuesday. And of these 420, 1/7 of them, which is 60, and there was 420, so it now has to be 360 left behind. Oh, and 1/7 of these guys is 70 and 420. All right. I think that's all the data for girls born on Tuesdays, girls born on Tuesdays, girls not born on Tuesdays, girls not born on Tuesdays, boys, boys. All right, so I have to analyze this, Cuthbert. Now, let's go through the two motivations. He's also said one of my children is a girl born on a Tuesday. So he chose somehow a child to talk about. Maybe he flipped a coin. In which case, if he flipped a coin, he says, okay, heads, I'll talk about my oldest, tails, I'll talk about my youngest. He flips a coin, gets an answer, says, oh, the child I just flipped on tells me to say girl born on a Tuesday. All right, so let's assume he did flip a coin to choose which child to talk about, and let's see what answer we get. All right, complicated. So where could Cuthbert be in this picture? We know he did say here's a girl born on a Tuesday. He cannot be one of these people with two boys. Because he can't say he's a girl born on Tuesday. So he's not in that part of the picture. All right, not there. Could it be this part of this 420? These 420 fathers have girls not born on a Tuesday and boys. Oh, nope, not them. There's no way you can say he has a girl born on Tuesday if you're one of part of that group. Or here, you're not part of that group. Or this part, these are the fathers of two girls not born on Tuesdays. In which case, nope, he did say he's a girl born on Tuesday. He's not part of that group. Now, what's left over? Of these 10 fathers here with two children, both born on Tuesdays, both girls, he would say whatever the coin does, yes, all 10 of them would make that statement. Of these fathers, 60s fathers here, they have one girl born on Tuesday and one girl not born on Tuesday. So with a coin flip, half of these will make this claim and half won't. So half of them will actually say that statement, half won't. Ditto for these folks, these 70 fathers, half have a girl born on Tuesday, half don't. In which case, with the flip of a coin, half will say, yes, I have a girl born on Tuesday, half don't. Ditto here. Half of these fathers have a girl born on a Tuesday, those girls there, half don't. Half of girls born on Tuesday, whoops, there, those don't. So of all the people we expect to make this statement, with the flip of a coin, it's going to be 10, 30, and 35, 30, and 35. There's a lot of people that will make that statement. In fact, that's what, 65, 130, 140 of them will make that statement. Now, what are the chances that he has two girls? Well, the chances are he's somewhere amongst these folks. These 30 fathers have two girls, two girls, two girls. So the chances are 70 out of, what did I say, 140? Whoops, this is Bilbert, this is Cuthbert. 70 out of 140, it's one half. It's one half. If Cuthbert flipped a coin to talk about which child he wants to choose and mention, then the answer is one half. That's the intuitive answer, but actually for very different reasons. One half. All right, now let's go back to the data we had before. Oh my gosh, can I remember what it was? These were 60s and 70s. All right, 60s and 70s. 60s and 70s. 60, 70, 60, 70. I believe that was 360, 420, 420, and 490. Whoops, my marker's running out, so goodbye to that marker. All right, so that's the data we had before. Now, let's do a different motivation for Cuthbert. Suppose Cuthbert lives in a society that says, you must mention you have a girl born on a Tuesday if you can, if you legitimately can. So that's the rules of the society. You must mention you have girls born on Tuesdays. Okay, so that was Cuthbert's motivation for saying, one of my children's a girl born on a Tuesday, then who's going to make that statement? Well, these folks aren't. Those were two boys. They won't say, I have a girl born on Tuesday. These folks won't. Boy, girl not on Tuesday. Again, these folks won't. Girl not on Tuesday, girl not on a Tuesday. These folks won't. Boy, girl not on a Tuesday. All 70 people here will. If they can mention that they have a girl born on a Tuesday, in which case they will say it in that society. These people will say it. They've got a girl born on Tuesday, therefore they'll say it in that society. Do it for these. These 70 fathers have a girl born on Tuesday, they'll say it, they'll say it, they'll say it. These are all the people that will make that statement. In which case, what's the probability they will have that Cuthbert's a father with two girls? Well, what's the chance he's one of these 130 people out of all these possible people who will make that claim? That's 130 plus another 70, 270 people. And you see that's the fraction 13/27. Whoa. So that's the issue with these probability problems. It's all about context. We don't know what motivated Bilbert to make his claim. We don't know what motivated Cuthbert to make his claim. So if we make guesses as to what the motivation was, you'll get different answers in probability theory. Everything is about context, and that's what I actually love about mathematics. People say mathematics is absolute, you have to have absolute answers all the time. Well, you kind of do, but there's always choices. You have to say, well, what's the context? Because different contexts will give different answers. Wow, deep and subtle. Now, here's my next question for you. Imagine Bilbert lived in a society that says, you must mention you have a boy child if you can. That changes that. Imagine Cuthbert lives in the same society. You must mention you have a male child if you can. That's going to change that answer. So, what answer do you get in those cases? Great stuff. Lots of deep thinking here. You might want to read the text below this and really think through slowly because I went through fast-paced, subtle thinking here, but it's great stuff.